Oh, Ashwin. Okay, for this time lah, I just so I so just we just see what can we do lah. Okay, like we look at this one for school, the school module. Right, the school module, Form 4, Chapter 2, page 16 to 19. Let's see. I think impulse follow through you already know lah, huh? So we continue here. This is a car collision. That's uh, oh no. I don't think it's that. I'm not sure anything. I just I just guess. All right, so now think okay, so hey Catherine, I see you again. How should I tell you? I just can say it might have force and acceleration. Okay. Then it might have specific heat capacity and specific latent heat. This one we already discussed in school, right? Okay. Then got refraction of light. Not light, sorry, it's waves. Wave means could be light wave, could be light wave, could be sound wave, could be light wave, sound wave, water waves. Okay, then this one also we discussed in school already. Okay, then chapter 3 also got either linear speed or centripetal force. I think so. Not so sure. Okay, then the rest, okay, maybe got lens and mirror. Normally got lens and mirror, sure will ask you the KFC or the Vroom rim race the characteristic lah. Normally if they ask this, sure got KFC and this is. Okay, then what else? Okay, the rest line, let's look at from 5-1. Okay, from 5-1, we look at from 5. This is from 5. Okay, from 5-1, we look at Pascal principle first. Okay, from 5, this is from 5. From 5. That day everyone get ready, right? If you haven't get yet, it's still in physics lab, in the school, in the box. Every class got one box. Maybe your module still there lah. I must come to school ma. Okay, so now page 1 out of the T, you can see diagram 1 shows a simple hydraulic pump with piston B surface greater than A. So if got this kind of Pascal principle, you must do what? You must tell the principle lah. So what is Pascal principle? The force is transmitted correctly throughout the fluid in an enclosed system. So this is the system that close all up. So we say enclosed system. Okay, so actually something wrong here. Anyone can tell me what's wrong? Okay, something wrong here. Anyone can tell what's wrong? No one knows. No one knows. Yeah, thank you, Daniel. Yeah, correct meh? Correct lah. Not correct lah. Yeah lah, transmitted. Yeah, first, uniformly, I forgot lah. Second is the force. Aduh. I want to tell you, last year, your senior, many people wrong here. Force acting on an area, piston area, will create pressure. So actually, it's pressure. Pressure is transmitted uniformly. Not correctly. It's transmitted uniformly throughout the fluid in an enclosed system. If I put equally, I can. Equally also can. Be careful, not force, but pressure. Okay. Okay, so now normally, so the pressure is the same. So if surface B is aided, what happened to the load? B is aided. So this one we need to think back the magnifying factor. What is magnifying factor? Magnifying factor will be A2 divided by A1. So normally A1 is small area. Small area. Then another area is big area. It's big area. Okay. So let's say B got 100 meters square. Then A is 10 meters square. So how much it magnified? So we use 100 divided by 10. It will be modified 10. So now what happened here? They ask if B is aided. So maybe A2 become 200 meters square. So what will be the factor? 200 divided by 10, you will get 20 times magnify the force. So F1 will become F2. Just now, let's say F1 is 100 Newton. So for F2 will be 1000 Newton. But now, the second case, 100 will become 2000 Newton. So what happened to the load? We say the load is easier to be lifted up. Why easier to be lifted up? Because magnifying factor increase. Means what? Means more output force. Up there we write F1, F2 lah. So normally we will say F1 is input force. Then F2 is output force. Like that. This surface area is directly proportional to force. Surface area is directly proportional to force. Directly proportional to force. I think can. Yes, can. You can say that. Because it's the factor about physics. Yes, can. For C, can I write? I write move upwards. Actually, no matter increase or not, see, it's already small and big, so sure move upwards one. You must have comparison. See, what happened if this is aided? Okay, so if you write like this, you say the piston B will move upwards. Sorry, the load will move upwards. Cannot, because originally can still, if you don't add the area, still will move upwards. Cannot. But if you shows the difference from the previous case, the load will move upwards faster. Means you got more force. Because net force equals to MA. So if you got more force, you go faster up. So remember, if you just say move upwards, cannot. This one, even though you don't add the surface in B, still can go faster. So remember, you must show the difference from before. All right, so now, so Pascal normally like this lah. Oh, and then yeah, like calculation, I think all of you very good already. Calculation, I think all of you very good. I think so. Think so. Okay, let's say lah. Normally they will do this lah. Let's say this one, A1 equals to 1 meters. Oh, I know what. A1 equals to 100 centimeters squared. A2 equals to 10 meters squared. F1 is 10 Newton. What is F2? Can you all do first? A1 equals to 100 centimeters squared. Last year got one question like this. Hi, Cashman. Okay, if Pascal principle is F1 over A1 equals to F2 over A2 lah. So we substitute 啦。海伟中，我看到你了，100啊。Oh no, no, no. So pressure 1 equals to pressure 2. Pressure equals to F over A. So we substitute 10 divided by F2, A2 10, 100. Is it? 100，100好像对。Yeah, what's wrong? What's wrong? What's wrong? Yeah, you need. Yes, change cm to m is cm squared to meter squared. 对了 change prefix. So how to change cm to meter squared? Okay, 100 cm to meter is 1 meter. Then 100 cm squared to meter squared. How much? So actually it is 100 times 10 powers of negative 4. Okay, times 10 powers of negative 4. So what we do? So F2 equals to 100 divided by 100 times 10 powers of negative 4. Answer will be answer will be 10,000 Newton. cm squared to meter squared. I like this method lah. I like this method. Last year trial got this question, change centimeter square to meter square. There are many ways lah. but I like this way. What is this way? I will say that 1 centimeter equals to 0.01 meter. But we can try to use the prefix form, which is 1 times 10 powers of negative 2, where we can just ignore the 1. So now, if I want to square cm, so I also need to square cm. I need to square meter. So it will be 1 square centimeter square equals to 10 powers of negative 4 meter square. So 1 square is 1. So 1 centimeter square equals to 1 times 10 powers of negative 4 meter square. So 100 centimeter square equals to 100 times 10 powers of negative 4 meter square. Okay. This one. We used to this, but we are not used to square. So now square is like this. So square, see, if your cm change to meter, 1 cm change to meter, we divided by 100. So when you want to divide 100, you also need to divide 100 square lah. Since you square here, you also divide 100 square. Like new variance, let's say variance 7.71. So new variance times 3, 3 also square. Yeah, it's maths. Yeah. I scored 8 for maths and maths. A long time never use already for maths. Okay, so or you can check something like this. See, actually, yeah, 1 meter is 100 cm. So if you want to change meter square to cm square, you need to use 100 cm times 100 cm. So actually it's 10,000 cm squared. So when you divide, you divide. So cm to meter is divide 100. Then if you square here, you also need to square the number you divide lah. So be careful, this one. So far, I saw last year they really got this. Last year trials, I forgot which year. So be careful lah. The normal one, you all want wrong one lah. As long as you know this. But the problem is remember the unit conversion. Alright, so now next Pascal principle. So if we want to modify the smaller the piston wide, F over A smaller means you will create bigger pressure here. This one as large as possible. Why? So that magnification factor is larger. So you can produce more output force. So F1, we also call it as input force. Then F2, we say output force. So if you can master most of the principle now, after trial, you just revise back, you focus on the concept you feel hard. Then can cover many already lah. And we still got chance to score A or just up a grade from your previous results. Okay, so Pascal principle. If this is cm square, no need hesitate. Just divide them. So A2 minus A1, no need hesitate, same. 1221 divided by 88. Done. Just be careful here. Okay, now let's say this is 88 cm squared, but this one is 1.22 m squared. Can So let's say is 88 cm squared to 1.22 m squared. How are you going to do? 1.22 m squared divided by 88 times what? M squared times 10 bars of how much? Yes, thank you, Daniel. Yeah, times 10 bars of -4. Yeah. So divided by 100 square actually means per 100 square means 1 per 10,000. 1, 2, 3, 4 means 10 bars of -4 lah. I think all of you now can memorize already, right? Yeah, can memorize already. Most of you okay already. Just the conversion of unit forgot the prefix. Because math seldom asks you change prefix. Okay, so it's multiplying factor. A2 divided by A1. This one easy lah. Okay, so now this one. What is the type of fluid we use? We normally use oil. Number one, oil incompressible. Cannot. You don't need compress it lah. Okay. What is it? Nah, this is a piston. Inside is air, right? See, if I push it, if I push it, I can compress the air, right? So means if I want to really push it down, I need to apply more force. So incompressible is the best. If you directly push, it will directly move forward. Okay. Then oil will not make will protect the metal, so will not rust easily. And some more oil is lower density than water. Yeah, I think many people will still think oil is denser than water. No, 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 no. You just think about curry meat. Normally what you eat, curry on top is oil, at the bottom is the soup. Soup is water lah. So oil is less dense than soup. Okay, low density. So it will be lighter or low mass. Then multiplying factor would be A2 divided by A1. The bigger the better. So once you divide, you can see this one 0 point something with one choke. So answer is Q. By the way, multiplying factor, you may ask teacher if multiplying factor, I get this kind of fraction, can I leave this in our answer? Do you think can or not? No, thank you. Yeah, no, I cannot leave it as fraction. Maths can. Physics we want decimal, so you will get 22.5. Okay. No unit because multiplying factor is a ratio. Okay. No matter how Pascal principle always use small input force to lift up some load lah. For dentist chair is a Pascal principle. And every Pascal principle taught the same thing lah. Small input force and create larger output force. So the rest so far I think will be exist in paper 1 only. Now let's look at resistance. Now see Pascal. So there are so many questions here. You try here, okay? They are almost the same thing. Again, Pascal principle. Again, the bridge. Fast, the bridge. How is Pascal principle for bridge? Which one is the best? We need to open like that so that the ship can pass through. Normally, car pass through when it's flat. Now we rise up so that the ship can pass through. Hydraulic bridge determine which one can open more, can be operate more effectively. Nice common sense. Physics got the benefit something common sense only. Q and Q. Okay, if this one you are not sure, never mind, we look common sense first. R, we look common sense first. If you want to lift up the bridge, large mass or small mass, Q. You want to lift it up, sure, you want to lift it up. The best, of course, is small mass. Small mass. You want to lift up lighter ma. So small mass, we say lighter. Please write more than one reason, okay? Lighter or low density lah. These three are packaged, okay? These three are packaged, okay? Okay, fluid use, gas or liquid? Gas. Don't want. So liquid. Yeah, so why? Because liquid incompressible. Okay, incompressible. So can save the force. I only can remember this now. Then release valve. Release valve means actually this one you need to press. Like release valve, you just press this. Everything will return to the same level. So exists better lah. Then now we actually can see already lah. It's Q. Then now see, cross-sectional area of large piston. Large piston must be the output one. Small piston must be the input one. So output over input bigger to smaller lah. So answer is Q. And I put pressure will be transmitted equally for liquid. Yeah. Very good. Pressure is transmitted equally throughout the liquid. Yeah, throughout the liquid. Very good. Okay. Okay, so release valve can return to original level, original position faster. Means when you press, psh, all of the liquid go back lah. Okay, so the ratio is output to input, so larger lah, larger. Okay, why larger? So that can create more output force. Output force. So for the hydraulic things, we always use input smaller, output larger. So that's all. So small piston means pressure, larger pressure exists. So I feel Pascal really easy lah. So this one. This one meter square, no problem lah. You just substitute lah. Just be careful, cm square. Okay. Okay, so next we look at resistance. So you can see many things you can try. Yeah, be careful here. What is like, look at chapter 3, page 1 out of 23, SPP question. Okay, so now what is the function of voltmeter? To determine the voltage, correct? Yes, yeah, yes. Thank you, Janwan. Thank you, Shunbing. Thank you, Chin Yu. Yay! To measure. No, determine. Okay, not determine. Measure. All right, so now to read cannot, because we want measure. To read, no. Measure always, when they ask function of measuring tools, always measure. All of this we call them as measuring instrument. So we always use the word measure or measuring tools. Measuring cylinder, stopwatch, whatever used to measure things, measure. Okay. Hi. Potential difference. Yeah. You can say potential difference. Or actually, for this case, you want to say EMF also can. So actually, under voltage got two, potential difference and EMF. Yeah, but they just ask voltmeter lah. So for Form 5, voltage still acceptable. But next level, Form 6, A level, you cannot use voltage anymore. You must mention potential difference or EMF. Now Form 5 still can use. Many EMF. EMF graph like this going down one. EMF. Oh, this one. This one is resistance. This one. Do I need to tell? Tell. So what is meant by this? So we need to translate this to P equals to E over T lah. So which is 1100 joules of energy is used in 1 second when it is connected to 240 volts. It is connected to 240 volts power supply. Power supply. Okay, so now be careful about resistance. This is chapter 3, Form 5, chapter 3, page 10 out of 23. Okay, so now resistance. We need to have two kind of resistance. High resistance and low resistance. When do we use high resistance and when do we use low resistance? I believe all of you know, right? Heating element must use high resistance. Low resistance for connecting wire. Now, for example, all of this will produce heat. So why high resistance can produce more heat? When you want to say produce heat, please always use the description produce more heat, right? Connecting wire, like your charger lah, charger wire, we use low resistance, so means can produce, not produce, can let more current to flow. Okay? Then this resistance depends on what? LATT, lat. Resistance depends on LATT. LATT, LATT, LATT. So L means length of wire. A means area of wire. Hi, Apple, 我看到你了，你要不要关 camera? Okay, so area means thickness. Means cross-sectional wire. This is wire, you cut it, you cross it. Normally, this cross-sectional wire is area equals to pi r squared. It's a circle. All of you, I believe your MS, the basic, you're all very good already lah. Okay, LATT. T is temperature, no, material. Type, type. One is temperature, temperature, and then this is type of material. LAMT, LATT, type of material. So, right, how to get high resistance? The length should be long. Means if got coil, more coil. Area should be thin, okay? Should be smaller, small or thin. T temperature should be higher. Type of material should be nichrome. Okay, so be careful about this. Then we got resistivity. resistivity. This one you can find in your formula. Resistivity equals to RL over A. And what is resistivity, right? Okay, how to we can do this. Resistivity equals to RA over L, RL over A. Sorry. R equals to rho L over A. Oh, sorry. So this is RA over rho L. So rho equals to RA over L. It's in your formula. I see. Didn't check formula. Too confident. So I hope you check formula. Yeah. R equals to rho L over A. So RA equals to rho L. Rho equals to RA over L. This is for resistance. So you terbalik, you shift them by algebraic formula, then you will get RA over L. And this is called resistivity. Last year also got this question. Then a lot of your senior don't know the area is area of circle. So they wrote. I hope this year you all alert lah. The area is cross-sectional area of the wire is a circle. Pi r squared. So if they give you diameter, please change diameter to radius. 可以吗？ Pi r square, not pi d, it's pi r square. Okay, then what is resistivity? Right, resistivity means we can use, so R is ohm, A is meter squared over meter. So if we simplify, we will get ohm meter. Okay, so we say resistivity means the resistance in unit of 1 meter wire or 1 meter conductor. 1 meter wire means 1 meter conductor. So if you want to describe heating element, you can say high resistance. One more, high resistivity. They are two different things. They are related, but they are two different things. Okay, so if you can recall what we practiced before, I always say high resistance, high resistivity lah. So same thing lah for heating element, high resistance, high resistivity. Connecting wire always slow lah. That's it lah. Okay. So if they are asking same concept, you can write same reason. You repeat twice also doesn't matter. Okay. Okay, then next, be careful. This is LED. Be careful, LED and filament bulb different. If you want brighter filament bulb, brighter means you must have greater resistance. For LED, you no need higher resistance. You must have low resistance. They are two different things. Okay. Filament bulb is the hotter, the brighter. So last year 2024 SPM got this question So they always ask like this light will be built. So the wire used in the lamp wiring system to reduce the electrical consumption. So actually, this is talking about connecting wire, not the filament itself. So you need to be careful. Two types of resistance. So you all can do that. Resistivity. Okay, now next we look at CRO. Is connecting wire parallel? Yeah, can see that sometimes parallel, sometimes. Most of the time parallel. So parallel means you off one, another one is not affected. This one, Fleming left-hand rules, you're all very good already, right? Now, this is a DC motor. Right? This is a DC motor. Right? Let's label the direction of current flow. Current always flow in the coil wire. Since they say coil wire means you must label inside here. You label here, no marks, So current come here. You can label that, of course, but you must make sure you label inside like this. And come up one mark for current. Please label I. Then the direction of motion of the coil wire. So how? Use your Fleming left hand. Anyone still not sure? Later you stay back a while. I teach you. If you are sure, no need. Okay, clockwise or anti-clockwise. So this one will go down first, then this one will go first. So this is 9 o'clock, this is 3 o'clock. So yeah, it's clockwise motion. So it's clockwise motion. Okay, it's clockwise motion. Okay, let's say if they ask you to draw the catapult field, how? So this is north and this is south. Here got. So the current go in means cross. Current go to you means stop. So let's say you see from here. This is what you see. How to draw the catapult force? Thank you, Qing. One line not enough. One line not enough. Yeah, correct. Yeah, please draw at least 5 now. 1, 2, 2, 3, 3. Fill up 4, 4, 5. So start from, thank you, Qing. Yeah, so start from here. Clockwise, we use right hand grid rules. Clockwise is, clockwise, dot means anti-clockwise, going down, going up. Clockwise means going down, going up. Okay, so you can see that going up means we can start from here first. This one maybe not affected. This one will be pulled up and follow, come back here. Pull down, follow, come back here. Pull like this, pull like this. So you will see lah, more lines to less line, more line to less line. That's catapult field. If you are not sure, you can use pencil. We'll draw all of the lines first. Then you will see, oh no, this one will be direct up and down. This one also direct because cannot. I'll say this is the roundabout. Roundabout. Okay. If you're not sure, later stay back a while. Okay. You can give me 10 more minutes. The DC one you all try lah see something like this try lah You all got answer also, right? Try lah DC now something like this. This one like it easy, cause one only, one conductor only. DC motor Then what else? Okay, radioactive. No need to talk. Oh, radioactive is radioactive decay. Okay, mass defect, everyone, okay? Mass defect means total mass before minus total mass after lah. Then you change to from AMU you change to kg. How to change? Do not worry. You just times this. Same thing like I told you before, 1 dozen of pen equals to 12 pence. So 0.75 dozen, 0.75 times 12. 1 AMU is this. So 0.75 times this, that's it lah. Okay, not so hard lah. Then if they want you to calculate the energy, E equals to mc squared. You change m into kg first, then only you remember 3 times 10 powers of 8 bracket square. C square, okay, bracket square. I'm the one who always forgets square. So I must make double check. Okay, you also Okay, then must memorize all of this. This one, control rod. A, B, C. Absorb, excess, neutron, boron, cadmium. Check back your textbook. Moderator, water and graphite. Slows down, SWG. Slows down excess electron, water and graphite. Uranium field, uranium. Then cooling system, safety, thickness of wall. Cooling system must be water lah, near to water. Oh yeah, one more things I forgot. But before that, we discussed already lah. We got a few types of nuclear reaction. Number one, nuclear fission. Fission means separate lah. Okay. Number two, nuclear fusion. Okay. Number three, fusion means two become one. Normally is hydrogen, deuterium, and tritium. Hydrogen plus hydrogen become helium. Okay, number three is alpha decay. Number four, beta decay. Number five, gamma decay. Yeah, I just remember last year we got one question. Let me see. Decay. Something. Let me check that last year. Selenium, 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 selenium. Oh, it's not. It's this. Be careful about this. This one actually means one alpha. Here got two beta and one alpha, two alpha. So for this one, if they show you this, got three alpha and two beta lah. And just remember the cross line. In the cross line is alpha, and this is beta and beta. Okay. Alamak. Set one. Oh, that's set two. When I find I send you all. So I think you all know how to, let's say X 23899. Let's say that it will become Y plus 1 alpha. You know how to solve this, right? So first of all, we change alpha to helium-42. So then, what is this? It will be 238 equals to unknown plus 4. So it will be 234. Then for this one, we will get 99. Put the arrow as equal sign plus 2. So it will be 97. Understand? So like that only lah. The alpha beta decay. But if problem is, the problem is if it is like, U23892 become X, Y, Z. 1, 2, 3, 4. 1, 2, 3, 6, 8. So from here, you got how many alpha, beta, gamma? I find out the question and I show you. Okay, like the last two. last one, photoelectric effect. So this is line spectrum. Please check back what is photon. You can directly check answer. And what is photoelectric? How about gamma, teacher? How it works? Gamma won't have anything because gamma is ray. So for example, let's say that 23892 uranium become 1 plus 1 gamma. Actually, this one still 23892. Just the mass becomes smaller. The mass become lighter. Nothing changed for proton number and nucleon number with gamma. Very good at us. Okay, so now this one will be photoelectric effect. Oh yeah, by the way, thermionic emission, CRO. You all also please check back, CRO. How CRO form? What is thermionic emission? What is photoelectric effect? Actually, both of them has almost the same thing. The same effect. What's the effect? Photoelectric effect is electron is emitted out. Electron is emitted out when a light wave certain frequency is shone, or we say is illuminated. If you feel cannot remember shone means 它照在那个 metal 上面 on a metal surface， 它照在那个金属板上面。Right? Then how is this? Copy and paste. Electron is emitted out when a metal surface is heated. So they looks like the same. Electron is emitted. Problem is this one use light, this one use heat. Can I say conductor? Metal conductor. Normally textbook always say metal lah. Okay, metal surface. And this one we already practice a lot, right? Minimum frequency, threshold frequency. What happened to the kinetic energy when intensity of light increases? Answer, no change. We practiced this before. Yeah, you can do it again. Because intensity of light will increase. You can imagine intensity of light means how many beam of light lah. So you got more beam of light, you got more number of electron go out at once. That kinetic energy depends on E equals to work function plus KE max. KE is photon energy equals to work function plus half MV, KE max. KE max. So photon is HF equals to HF naught plus half MV squared. Okay. Now this is the same thing, photoelectric effect. So why we got photoelectric effect? Because got light. So means the electron will travel inside. When electron flows inside, means it will produce current. Current also flows. Oh yeah, by the way, just now, thermionic emission. This one also need to study CRO. Thermionic emission means it will produce cathode ray. The electron emitted, we call it as cathode ray lah. So cathode ray will be attracted to anode. Then it will produce the green light if got the screen, fluorescent screen. Okay. Now work function, threshold frequency, work function, HFE. Then almost the same thing only. Do not worry too much. That's it. Okay. Any other questions? Okay, if you need help for Fleming left-hand rules, you can stay back a while. If not, you can go rehat already. Okay, thank you everyone. Bye-bye. Thank you. Bye-bye. Bye, Kaya. Bye. Bye, Daniel. Welcome. Okay, so I think, okay lah, Fleming left-hand rule. Fleming left-hand rule. Left-hand. Okay, so now, bye. Okay, like, so I think you stay here because you need help of Fleming left-hand rules. Then you turn to this is, you can turn to the center, it's on 5 chapter 4, I think. So it's 28 out of 30. Okay, 28 out of 30 lah. Okay, so now how is the current flow? Anyone can tell me, or you draw it by using annotate. Hello. What is the current flow? Current flow. Can you label the current flow? Thank you, Tiffany. Correct. Positive to negative. Yeah, correct. Positive to negative. Thank you very much. Yes. Okay, then it will the direction of current always from north to south lah. Then now what we do, okay, so you can just draw the XYZ axis first. So X axis will be the north and south lah. So this is your X axis. So we will point. So then up and down. Don't know what is it first. Never mind. Then this is sec. Sec will be direction of current flow lah. So like Fleming left-hand rules got 3 finger. This is father. This is mother. This is I. Father, mother, I. Force magnetic current. Okay, if you feel hard to remember, it's okay. You You don't write it in before you enter the class, but you can draw it while you are in during the exam. So this is going up. You treat your fingernail as arrow. So this is father, this is mother, this is I. Oh, cannot write. Father, mother, I. Father, mother, I. Okay, so we always follow mother first. Mother always point to south. So how I remember in this way, mother go shopping. So mother point to south means now this is your left hand side, right? Use your left hand, put magnet mother to left hand side. Sure. Can see that? Then you will see the middle finger go up. So it will be AB side. So so this one fulfill what? This one fulfill your force going up. Then another side is your force going to your way. So how? You remember how you fix to your left already, you cannot do. You just change like this. So now you will see the middle finger point to yourself. So the force going down, going down. Okay. Then if we see from this side, we'll see this is our left hand side, this is our right hand side. Look at the clock. The clock also 9 and 3. So left hand side is 9 o'clock, right hand side is 3 o'clock. 3 o'clock going down, 9 o'clock going up means it will go clockwise direction. Okay. I think not. I think not. Okay. If you faham, very good. If you faham, very good. Thank you. Faham, behe. Yeah. Yeah. Okay. I think another 4% not so understand, right? The yes, 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 yes. Always set where you no. Always see 3 and 9 always fixed. This is a clock. Just north and south they set. So can no anti-clockwise? Can see? Normally 3 go down to 9 o'clock and come back to 3. So this is clockwise. Since 9 o'clock the force go up, 3 o'clock the force goes down, so it will be clockwise. So it will be clockwise. Okay. Okay, and I should ask. Yeah, just now I didn't ask about that. Like, so this is a motor. This one, this is a brush motor. Then which one is most suitable to lift a heavy object more effectively? Um, okay, first of all, number of coil. The more, the better lah. Density of coil means if you want the coil to move faster, your density should be move faster. You want to move something faster. Yeah, so should be low density lah. For example, you got a fan, Chinese fan. If it's light, you can swing faster. If it's heavy, wow, hard to swing faster. Strength of magnet, of course, must be high, no? Then you can see already, lah. Can see common sense. So that's why I like physics, common sense, right? I want to move something, low density, greater strength, more number of coil, then number of segment is more. Answer is M. Motor. Motor. Hmm. If possible, you all do as much as possible. Okay.
See what happens when spinning wheel like that motor. The part that electromagnet stronger torque means a
stronger torque.
faster spin. There are some things.
Can you see more segment? More segment in commutator. So turn faster, greater strength. How to write? Greater strength, then you will get greater catapult field. Remember what is catapult field? It's a resultant magnetic field from the magnetic field of permanent magnet produce. You can say strength of permanent magnet produce greater catapult field. You can say it will have greater magnetic field. Field means there is a force inside lah. Number of turns of coil, more current flows. More current flows means what? It will produce. CCC means it will produce greater temporary magnetic field. Greater electromagnetic field also can. Density, low mass. Turn faster. Turn faster. Turn faster. More segmented in commutator, you can say I don't know. This one, I don't know. Let me check answer. Error. Error. Opera light. Not this. Please, not this. Electromagnetic. Heraclita, Miracle, Hera, 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 Hera. Okay. Require low energy to start rotation or low force needed to start rotation. Oh, okay, go now. Bye. Okay lah. So that's all for today lah. Okay. Thank you everyone. Okay, bye bye. Goodbye.